waterlogging, weed growth, as well as soil compaction causes 50% or more losses in ginger yields among Malaysian ginger smallholders. This is due to the poor, we identified the root cause is due to poor in-season management of ridge and drain. So, to solve this problem, our group developed Gingerguard, which is a holistic, affordable solution that prevents spread of soil diseases, prevents waterlogging, prevents weeds, and soil compaction by allowing ease of access to smallholders to maintain their ridge drain geometry. Especially when it rains, they can rebuild the ridge drain geometry very easily using our product. As well as, it also includes a walk along weeding feature as well as topsoil aeration. So this is our benchmarking. So on the left there, you can see our user needs. We have a ridge management system, which accounts for the ridge as well as the drain. And then we have the weed and soil aeration system as well as the portability and tidy efficient. So so we compared our products to three different solutions that are currently in the market, which is a powered tiller, mold board, wing shaper. We have also manual sweeping and uprooting, which is what is commonly used in among Malaysian ginger smallholders. We also have the farmer rig. So you can see that the farmer rig as well as the manual sweeping and uprooting does fulfill one of the user needs, which is weeding and soil aeration system. But our local farmers really like on the ridge management as well as the portability. So when you use your manual sweeping, it is very inefficient because you have to use your hands and you have to tend to each plant. So for competitor analysis, gas powered tiller and mobile wings usually do not reach the market of smallholders due to their primary price. So this is why abroad farmers are using it, but our farmers are not using it because they are intimidated by the competitive or like unjustifiable price. So this is our system architecture. So we have three systems: the ridge and drain management system, which is comprising of the tiller as well as the mobile wing shaper. So the tiller breaks the soil and the shaper shapes the ridge. And then we also have weeding and soil aeration system, which is here. The claw on the mobile wing shaper, as well as portability. So by implementing these three systems, we will ensure that the solution is very the solution fulfills all the needs of our farmers. So this is our design spec. For engineering targets, this is what we have for our ridge and drain management system. We outline the depth and width of the drain, and then we outline the penetration and shear pressure, which is what needs to be accomplished to break the soil up, so that the shaper can shape the ridge easily. And then we also have weeding and soil aeration system. So we have the full force to uproot the weed. So this is the amount of force on average to uproot the majority types of weeds. So and then we also compare it to field capacity to uproot weed. So we want our solution to be more efficient than manual hand weeding. And then for portable handling, we want to ensure that the frame is intact when it's used and the tire does not sink into the soil when we use it. So the distribution of forces must be correct. So this is for the ridge shaper.
Okay, so now we move to the design analysis. So I present about the ridge shaper, how we find the dimension and all the parameter for the ridge shaper for the ridge. Okay, firstly, for our objective is to find the length of the shaper and the opening angle, which means the angle between the two shapers. And also we want to know the deflection angle of the wing. So we will shape the ridge to the optimum shape for the ginger growth. Okay, so we start with the ridge shaper parameter first. Firstly, we use this okay, we use this height and width based on the shape ridge itself, and the opening angle is based by the research academic paper. And then the thickness also from the standardized from the Department of Agriculture of Philippines. Then, so by using the Trigo, we got the 600 mm for the length of the shaper. And then we move to we move to the calculation to know the deflection angle of the shaper. So we use the 2D visualization to know how our calculation should fit this ridge. So same, we use the Trigo, and then after that we got the angle of the deflection of the shaper to achieve the optimal shape of the ridge is 153.40.
And then we have for the breeding and everything as well.
So for to aerate the ginger's ridge, we need to aerate the ginger ridge because ginger requires aeration so that they don't lose oxygen, because later on it will cause the rhizome, which is the gingers, to rot. So from the research, the ridge-grown ginger, this is they grow to 120 to 150 millimeter from the ridge surface. So we also need to apply engineering safety factor, which is around 20 to 30 millimeter. So the spike length for the aeration will be 120 millimeter. Because why we need engineering safety factor? Because so this is the soil surface, and this is where the ginger is grown. So we need to aerate the soil, but we don't want the spike to touch the ginger, because if it poke, then it will rot, right? So we want to avoid that. Therefore, we add safety clearance 20 to 30 millimeter. Why this specific 20 to 30 millimeter? Because we don't know, because the ginger is not exact. Every ginger in that one row of which is grown exact the same sizes. Therefore, we take this safety clearance to make sure that our spike doesn't touch the ginger.
Okay, so for the weeding system, since we're going to be using the same function system as the aerating block, we're going to use the same dimension to find the area. So this is the shear strength to break soil adhesion, and then finding the area, we can find the force that one spike emits. So it is shown to be 30 to 60 newtons based on all of this.
Okay, the design is for the portability tire. We use engineering target, tire contact pressure, pushing force, and rolling resistance coefficient to find the diameter of the wheel. So the first one, we use the summation of Fx, Fy, and then the total of each component, and the total weight, and then we rearrange of the friction force to get the minimum diameter. For the handle, we use three equations, which is the applied force, and the bending moment, and also the bending stress to get the length of the handle.
So this is our prototyping process. We'll skip this. This is our video. Because our current product is not fully developed yet, we weren't able to do any validation, but these are our test cards. So for socio-environmental impact, we have the society impact, which is affordable for the farmers, which will decrease losses among smallholders, and the average production of ginger if production will be increased nationwide. So for the environmental impact, okay, so let's go through the slides. And yeah.
So what are the part that is not complete yet?
The part that is not complete is the ridge management. So ridge management, as we recall, we have two components, which is the
Ridge management is
ridge and drain
tiller.
management.
What?
Yeah. So the claw, the shaper is complete, but the tiller is not completed yet.
Shaper is complete.
Yeah. So
Tiller is not yet.
shaper is the one at the back here.
Hold on. Shaper. Shaper is complete. Okay. Alright.
So this is the shaper. So the front part, which is the part that breaks up the soil, is not complete yet.
So yeah, there is no. It cannot.
But we've already
It's not even reached the ground yet.
the
This part, right? Because it's not finished yet, right? Or have you tried something?
yeah, we've tried using the ridge shaper here. From the video, we actually tested on green sand.
Oh, I didn't notice. It's okay, I can wait. What's that? What's that? Pink, sharp.
That's fine, yeah. So that's the one that's going to penetrate the soil and aerate the top layer of the soil, as well as
Okay, continue.
break up the soil.
Oh,
Oh,
it's not there, is it?
Small
okay. No. Okay.
Okay.
This part.
Okay.
So this is where we tested the so this
It's okay. So it will like separate, makes the sand go
yeah, so
separate.
it's going to push the soil to the side. So we tested it on green sand because green sand is it simulates the properties of broken up loam soil. So that's why we tested it on green sand. So for validation, actually this part for the shaper is validated. We tested it. This is a 1 to 2 scale prototype, and we got 5 centimeters of ridge height. So, but we didn't put that in the slides, of course.
Okay, that wheel in front, that was not supposed to be like that. It's supposed to be a tiller, right? Correct? Tiller, right?
So
Okay.
So the
You have done it?
in front of the tire should be the tiller.
You have done it or not yet?
We've cut out all the parts, but we haven't welded it together.
I like the judges first. The supervisor first.
So these are the plans that you are trying to do
Okay.
after you settle with all the tillers and everything, right?
Yes.
At the time,
So,
well, okay, first is to reconstruct the ridge. What do you mean by that?
so reconstructing the ridge basically means to push the soil towards to the top of the ridge. So if we go back to the start here, I actually have a picture of what the ridge is. So by what I mean by pushing the soil to the top of the ridge is this is the ridge and this is the drain. So basically when you break up the soil and there's surplus of soil in the drain, you push it onto the ridge to ensure that the ridge is at a certain height.
So there is like reconstructing. So,
Yeah. So that's what it means.
so you have a target of certain height.
Yes.
Can that be pushed right now?
Yeah, you can push it. we tested it in
So in your
Okay.
view,
Alright, so your intention from the first place, you want to scale it down or what?
yeah,
If
because
you from the beginning itself you wanted to scale it down, then why you choose all those metals like
you mean the material
you
choice?
you can do the easier way, right, to achieve that function.
For the
Like-
soil bushing.
It's like instead of doing all those welding thing, maybe
Because-
perhaps using pipes,
We
connect it together.
we needed the structural integrity of the metal.
Okay.
So initially we
Okay,
thought-
but why you chose to tackle the structure integrity first instead of the functionality itself? Supposedly, I think you should like design the wheel first, push it like maybe you don't have this kind of structure first, like you can like holding it at the sides and try it, and then you continue from there doing the handles. But you do that handle first. I don't know. See, like I mean the priority.
So from what we understand from the proof of concept or prototyping lecture
Mhm.
is that we need to demonstrate the functionality of the or the mechanism of our solution itself.
Okay.
So to demonstrate this mechanism,
Mm.
we need to have the motor, which is heavy, we need to have the battery, which is heavy as well, and we need to be able to push the soil. So to push the soil, the shaper actually undergoes under a lot of strain
Hold on.
and stress.
Where's the motor? I mean, can I see the cat?
Okay.
Where the motor is supposed to be?
This picture is actually from our chapter 2 report.
Okay, it's okay. Where the motor is supposed to be? It has to be powered up. What?
So the motor is supposed to be connected to
The tiller.
the shaft. Yeah.
The tiller.
Yeah.
So, okay. So it's not like it's rolling by you pushing.
Our hands don't break up the soil. So
Okay, so like you hold the handle, lift it up a little bit, and the motor will,
yeah. So it will break up the soil. And once it breaks up the soil,
and your face will get the dirt.
that's why we have the shield. That's why we have the shield.
Okay.
So yeah. But if you look back into the
Still a long way, you know. Right. What's your plan for next week? Actually, you want to show something like this to the judges?
no, we just need to weld the thing in place. So
Yeah, it's like that's why I said the priority.
yeah, actually,
There's no bolts or the.
there is both. Yeah, there is both for the killer. So if we do in here on the part, so the shaft is actually the killer blade is actually bolted onto the shaft by
Cylinder itself is also complicated. You have the design analysis for this particular?
I have the design analysis,
Is it
but
shown here or?
we didn't show it here because we don't have it shows. So
Can be reflected in your report?
yeah.
Anyway, wish you all the best within this one.
Yeah, I have a question.
Uh,
Regarding your problem statement. Sorry, problem solution. The second slide. Yeah, no, yeah, I do 50%. Okay, problem identification. I can see the relation, the problem with your design specs, especially in the portable handling. So is there any problem statement that you can show to me or to our judges here related to the portable handling for the user?
information is regarding
Usually, yeah, it's based on this problem statement and also your design spec, especially for the portable handling. So, is there any relation with your problem solution that you mentioned just now? With the portable handling?
It's not, but it's related with our benchmarking. So because
No, I refer to the problem solution.
problem statement of
Then how you can identify the user need that portable? What
because
is the problem regarding the project or with the product that you use?
because we classification we analyze our competitors, which is the power dealer here. So they use a push along region as well. So that's where the probability aspect came. They use it.
You are referring to the problem statement.
The problem statement is not for the probability.
Then,
The problem statement is
okay, then my second question is regarding your portable handling, also user need. Which design analysis that you can prove? Which design analysis that you can prove for the portable handling? So in your portable handling, your engineering target is 30 to 60 kilopascal, and then coefficient of rolling resistance is 200, pushing factor less than 245. So is it this one?
so the portability usually is actually referring to how do I say?
So based on your design spec, portable handling, you based on the design spec, portable handling, your engineering target is there. So there are 5 items there. Okay.
So basically we have
No, the engineering target is 5 items. 30 until 60 kilopascal and until that one. So which engineering analysis that you can prove to us?
under study.
For the 30 to 60 kilopascal is for the tire.
30 to 60 pascal for the tire. Contact pressure. So which one?
Oh, it's actually used for the contact area.
Basically, we find from the target contact pressure to allow the tire to walk on the farmland. We find that the tire contact area should be
Okay. How about the pushing force? Less than 245 meters? That's for your engineering target?
For the pushing force used in this summation, X summation, and then we use this to find the radius of the wave.
So actually in your portable handling user need, what you target? Which component? Tire or handles? Because too many design characteristics here, so there are 5. So which one the most important? contact pressure. So okay, your engineering target 60 kilopascal. So which calculation or which justification that your design is rated for 60 kilopascal or reach that value?
I'm not into any slide on that calculation.
Is there any backup slide?
No.
In your report? Is it your include? Okay, so I suggest you to include in your report. Okay? Alright, thank you.
Okay, I think last one lah. What's your plan on the tiller? How are you going to do it?
So
How are you going to proceed?
we have the frame for the motor.
Okay.
We have the pieces cut out for the frame of the tiller as well as the shaft. So
I mean, okay. The tiller will be in front of that wheel, right?
yeah, it's right.
Okay, so like you might need to drill, or maybe it's already some fixing over there that can be shared, right?
So it's welded onto the.
Can you just tilt a little bit? That trolley I want to see. It's just blank, is it?
Yeah.
So you need to drill.
We just weld it together.
Oh, you just weld.
Yeah.
Well, okay. So yeah, you're almost there actually.
Yeah.
Like designing that tiller, and then put it welded, right?
Yeah.
It's either welded or maybe drill and put bolts. Yeah.
And the battery is supposed to be up here.
Okay. So okay lah. So just do your best to complete it as much as you can. Okay. Because the impression is not really good if you show something like this. It's somehow maybe it's a little bit hard. I must say it's a little bit embarrassing.
Right.
Okay. Make it better. Okay.
Right.
Okay. That's it from me. My comment. Thank you.
Thank you.